Hello and welcome to the SQL Bits 2020 virtual conference and to the session on designing and building a data model to tell a story with Power BI. My name is Rishi. I'm a principal consultant at Altius. We're a data and AI company in the UK, now part of Avanade. I'm a Microsoft MVP, Data Platform MVP, and a chartered accountant by background. I run two main communities at the moment, LearnDataInsights.com, which is all around helping people prepare for Microsoft exams, such as the DA100, with quizzes and courses, and PowerPlatformFinance.com, where we run fortnightly webinars on topics related to the finance sector and bringing in how to use Power Platform to help with that. So this session, I wanted to take a step back from the technical aspects of Power BI and look at some of those business analysis aspects. So how you capture requirements, how you design your data model using some of these data model design principles, Kimball methodology largely. It's not going to be a technical session, but I hope you still find it really interesting. And if you have any questions, please feel free to reach out to me. So there are 4 key steps to designing and building a data model to tell a story in Power BI. The first is to know your audience. The second is to complete a scoping template. The third is to define the data granularity and scope. And the fourth is to conceptually design a data model. Here we're going to look at the first step, know your audience. So you need to build a Power BI report. And where do you start? Do you start with capturing requirements? Do you start with doing some data analysis? Or do you start with designing an architecture for Power BI? How do you go from data to a nice data visualization? And in Power BI, it's very tempting to just put some data into the Power BI data model and start producing some visuals, because you could produce something that looks quite good really quickly. But this is often a mistake, because the right place to start with Power BI isn't with data and visualization, but actually with the business questions that you want the report to answer. So to do this, we start with user stories. And the definition of a user story from Wikipedia is an informal natural language description of one or more features of a software system, often written from the perspective of an end user or user of a system. So it's from that end user perspective, what do they want to be able to do as features of a system? The format of a user story is that as user X, I want to be able to do Y so that I can achieve Z. And all of these aspects are really important. So if we think about it from a finance example, say a product controller. So as a product controller, I want to be able to drill down into individual financial transactions so that I can reconcile the system outputs. And being able to have the so what on there is also really important, to be able to understand the so what. What are you actually going to do with this data? Why do you need this particular data? So having it in this format of a user story will really help you to get to the bottom of that. So let's look at some examples. So we've got 3 individuals here in a finance team who we want to capture user stories for. So we've got Helen, who's a senior finance manager, Martin, who's a financial controller, and John, who's a financial analyst. Let's take Helen first. So as a senior finance manager, she wants to be able to query and analyze detailed profit and loss and balance sheet data so that she can prepare the monthly accounts and management reports. Financial controller Martin, he wants to be able to drill down from financial statements into individual transactions so that he can manage accruals, the results, and monthly journals. And then also we've got financial analyst John. He wants to be able to understand the trends in cash flow and likely future balances so that he can support the cash flow forecasting process. So once we've captured these different types of requirements, and they're all slightly different, we could look at whether actually one report will meet the needs of all 3 of these individuals, or whether we have to build separate reports for different audiences. And even then, we can share the same data model. So having multiple reports that each answer a particular set of user stories isn't a problem. The bulk of the work is going to be in building a data model. And then once we've built that data model, we can use that as a shared data set. But the really important thing to capture here, as I say, is the so what. It's the so that you can do what. Because the important thing to know is that all the metrics and the data model and the visualizations that you produce have to be actionable. And that's what that bit really gets to at the end. So the next step in designing a data model is to complete a scoping template. And this template will allow us to take those user stories and be able to identify the business questions that we want our report to capture. And the template is a simple Word document that I use in many of my community and commercial examples, and that you can download from the link shown here. And it's a few headings in here which are quite high level. So it starts with a user audience, and this is the user audience of the user story. The dashboard area is the subject area of that user story, and the problem statement is that user story requirement expressed as a problem statement. Ideally something which is actually worrying the individual that they need to do, or something that they need to solve as part of their job. We then have the key questions that they'd want to answer from a report, from a data visualization that would help them with that problem statement. And then we have the KPIs and measures that would help to answer those questions. What would you want to view and filter those KPIs and measures by? And at a very high level, what kind of data sources do we need in order to be able to have those measures and have those attributes to be able to slice and dice by? So let's look at this with an example. So we started with Helen, finance manager, as one of our user stories, and she was particularly interested in income statement reporting. And her problem statement, I mean, this is more phrased here as a requirement than a problem statement per se, but she wanted to get that high level view of monthly, quarterly and year-to-date performance and the drivers behind that performance, but also have the ability to drill down into income statement heading or GL, general ledger, account level detail. And perhaps this is something she's not able to do with the current, say, Excel-based reports. And then we want to think about the questions that she would have, or and obviously we have a conversation with Helen. We find out these questions. We tease out these questions from those conversations. And what's really important when trying to identify these questions is to understand the context behind the data. So it's not about just putting numbers on a report, but actually being able to show sufficient context so that Helen can look at this report and know whether the numbers are good or bad. Is the financial performance favourable or unfavourable? And to do that, we need to ask the right kind of questions. So let's look at some examples. We can see, what is my revenue and profit for this month or this quarter or for year to date? Am I doing better or worse compared to the same period last year and compared to budget? And that's really important for that context. We know whether, not just the revenue and profit numbers, but actually are they better or worse compared to budget or to same period last year, and how much better or worse? And then for a given month or a given quarter or year to date, what were they at the start of that period or for the last month? And then what are they now at the end of this period or for the current month? And what does that look like in terms of that movement? So again, it's comparison. It's for you to be able to look at things, and this is particularly useful for balances, but also for numbers like monthly snapshot numbers like profit and revenue as well. And then we actually want to know, well, which organizational units have contributed most to that difference. So if we can see that we had a profit last year or the start of January and of this month, and then now we've got for this month we've got a profit of this amount, which organizational units have seen that increase in profit and monthly profit, and which ones have seen the decrease between those two periods? And that will allow us to really understand what's driving that number. And then once we can do that, we want to then understand what's within the organizational unit. What are those revenues and costs and profit numbers being driven by? So again, we can focus then on a particular operation, so a particular organizational unit such as USA or Pacific operations in this data set that we're working with, and what is the performance of that unit compared to last year and compared to budget. And we don't need to worry about how we're going to visualize this. It could be a drill through page, it could be cross filtering. That's not important at this stage. We'll come to that when we come to storyboarding. But for now, we need to be able to know what we want those visuals to be able to answer in terms of the questions. So then, based on those questions, what are the KPIs and measures that would help to answer those? Well, we're going to have actuals and budget numbers because we want to compare actuals to budget, and we want to compare it both for current and prior year. So we'll need to make sure we have all of those sets of numbers. And the particular metrics we're interested in are revenue, gross profit, profit before tax, and profit after tax. We'll also need to have a measure that will have our variance to prior year. So is it and both in absolute and percentage terms. Now these are fairly straightforward measures, and you should try and keep these measures as simple as possible. But sometimes you will need to capture more detail around these measures, such as what's the formula, what's the definition of that metric, and who owns the data behind it. And that's something we'll come to look at slightly later in a metrics tracking spreadsheet. But for now, for this purpose, for this template, it's good to just keep it very high level. And then we look at what do we want to view and filter those measures by. So, in order to be able to answer those questions, we need to be able to view and filter them by time, by year and month, and for quarter and for year to date. And we'd also be able to need to look at them by organizational unit. And we'd want to be able to drill down. We want to have that income statement or general ledger line hierarchy. So going from your statement header to your subheader to your GL line. So for example, you could see on your income statement your operating expenses. You can see your total operating expenses of say 200,000, and then drill that down into, well, what are they made up of the different components. So it might be, for example, depreciation, amortization would be your next level heading, and then we want to drill down even further into say amortization of goodwill. So we could drill down that hierarchy, and this is quite important to bring out these kind of hierarchies here as well as part of this scoping template. And then we've got data sources, and again, we could go into lots of detail here, but we want to keep this fairly high level. We just need the kind of data that we have that would be able to answer this. So we've got monthly transactional extracts, and again, available to download in CSV format, and you'll see if you download that, you'll all the way from 2005 to May 2008 monthly extracts. And we also have a spreadsheet with reference data. So it's got things like dates, GL accounts, departments, organizations, and those headers. So that data together will help us to be able to answer those questions. And now we've got these key questions that we could use both to design our data model, and then also when we come to storyboard, we'll understand how to help the visuals that we need and how to build that story with the data. So the focus of this is obviously a data model, but what I want to do is show how these key questions translate into an end report, just so you can get a little bit of an appreciation for the importance of these questions, but also how to actually tell a story with this data. And then we'll focus on the data modeling aspects of it. So if we look at the key questions, so we want to do, what is my revenue and profit for this month, quarter, or year to date? Am I doing better or worse compared to the same period last year and compared to budget? And how much better or worse? And if we now look at the actual report, we can see straight away we have those numbers there at the top. So we have revenue, gross profit, profit before tax, and profit after tax. And not just the numbers, but also the context, the prior year value, and an indication as to whether it is better or worse, so favourable or unfavourable. So the signs could be reversed for cost versus revenue and profit. But here we can see, using colour sparingly, we've got a green arrow for favourable changes and a red arrow for unfavourable changes, and up or down indicating whether it's gone up or down. So that allows us to see it straight away for those key metrics to answer that first question, and for also to be able to see it for any given period. So we can see for here, we're looking at it for the latest month, 2008 May, but we can go back to any period, look at it for any month in the past, and we're looking at a monthly view, so for May 2008, but we can also switch it to look for quarter to date, and it will look at quarter to date to May 2008, or year to date, where it will show us a year to date number, and all of these then reflect those. So this answers this top question straight off the bat as soon as you look at this report. Our next question was around looking at, for a given month, quarter, year to date, what were your revenues, costs, or profits at the start of the period, or for the first month of the period, and for the end of the period or the last month. So here's what we can answer for a waterfall chart. Now, waterfall charts are usually well designed for balances, so maybe for a balance sheet rather than income statement. But here again, it's really useful to be able to see context, or to be able to see what's driving a difference in this case between, say, start balance and end balance, or in our case, say, between month to date profit, monthly profit last month, and monthly profit this month. So we can see here, start of month is the monthly profit last month, and end of month is this month, and we can see that comparison and that difference, which organizational units have seen an increase in monthly profit and which ones have seen a decrease. So we can see Pacific Operations has had an increase, and actually our profit is lower this month, and that's largely due to North American operations and Europe operations, and it's showing monthly, but if we switch that view to quarter to date, we can then, this shows at the start of the quarter, so for April profits, and then this is quarter to date profits, so April and May, and we can then see actually we've got less profits because we suffered some losses clearly between then, and we can see most of those losses have come from, actually all of those losses have come from European operations. So our profit for 2 months there is actually less than our profit for the month of April, and we can see what's causing that. So actually there's been an increase in profit for North America and Pacific, and we can do that for year to date, and we'll see it from the start of the year, so January, and then through to year to date profits for May, and again see that variance. And this is all by default based on by default net profit, but if we click on a particular line here in their income statement, now this is reflecting revenue. So now this is our revenue in January and our year-to-date revenue. And we can, if we used an income statement which is more detailed, and we could drill down into individual GL lines and see that waterfall representation. So that helps us to really then be able to see both those next two questions in terms of which organizational units have contributed most to the difference, and then also here, what is the breakdown of profit for a given organizational unit. So we can see here the ones that we might be interested in. So if we switch back to looking at profits for month to date, we can see European operations would be quite interesting to look at because it's suffered some heavy losses. And if we click on that, we're making use of cross filter here. So we could use a drill down page. There's a few ways that we could drill into looking at a particular organizational units, but here we're just making use of cross filtering. So now this whole page is reflecting European operations. So we can see its revenue and its gross profit and its profit before tax, and we can see gross profit and profit before tax have both gone down. So there's something to really do with its expenses, even though its revenue's gone up. So we can start to look at those particular expenses and again drill down into detail and understand what's driving those variances. So hopefully that gives you an idea of how we might be able to answer some of those questions. And these are the KPIs and measures that are used in that report, and these are the things that we're filtering by. So it's really useful, I think, to be able to see how those questions then translate into an end report. So before we move away from scoping, let's have a look at metric tracking. So in our scoping template, we listed out the metrics, just a description of those metrics that we wanted to have in our report. But as I say, sometimes we need a little bit more detail on those. And again, I've produced another template and downloadable at this link shown here, where we can see the metric name and we can capture details around a particular metric that we have in our scoping template. So we have the name of the metric, we have the area and domain, and this is coming from that same column on the scoping template. What is the dashboard or area? Who is it requested by? So this is really where the user story is, or also the user in the first column of that scoping template. The user story specifically that this relates to. The definition of the metric, so we've got cost income ratio, and the definition is the total operating expenses divided by total revenue, so something quite simple. The formula, and here we don't need to write DAX or put it in any complicated structure, just simple formulas that are commonly used in Excel, or even simpler than that. So here, sum of operating expenses divided by sum of revenue. So someone reading this can just understand what that metric calculation is. The format of the metric, so in this case we're saying we want it to be a percentage to 2 decimal places. The data source for that metric, so where is the data for this metric calculation coming from? So in this case it's coming from a trial balance, the extract from our accounting system. The frequency of update, so perhaps monthly, quarterly, whenever that data is getting refreshed, we can update this metric. The data owner, so we again say here that the owner of that trial balance data is Martin, who's our financial controller. any security we need, and this will help to inform any particular row level security we might need in a report. And we might have different types of reports with a set of metrics that we need to put some security around. So here we're saying the security would be only visible to the finance team, and any alerts. So one of the features in Power BI is the ability to be able to have some metrics that you pin to a dashboard and then set up an alert on those metrics, so if they exceed a particular threshold. So here, for example, we're saying that Helen, the finance manager, should be alerted if the ratio exceeds 60%. So, I mean, we can always feel free to add or remove columns from here as is fit for your organization. But here is an idea for how you could capture a little bit more detail around some of those metrics that we have in the scoping template. Now we come to actually look at the data. So up until now, we haven't done this exercise, the scoping exercise, blind to the data. We've looked at the kind of data we have available and the kind of questions we've thought about, the kind of questions we might be able to answer from those. But now we're going to get a really deep understanding of our data, how it's structured, what it means, and how to build out those tables that can then relate to each other in the data model that we want. So for this, I wanted to use a slightly more complicated example than the simple income statement one that we'd be looking at. So this is some finance data from Xero as a sample. And here we can see the first tab of that is the trial balance. So we've got for each month, so for the month end date, for an account ID, we've got a debit value, a credit value, year-to-date debit, year-to-date credit, organizational name, organizational short code. And then if we scroll across to the different tabs, we've got a worksheet that's got some data on the organizations, the line item detail against journals. So against here, we're looking at this journal ID. We've then got reference, journal number, journal date, journal created date, account again. And we can see that some of these things will clearly relate to other areas, but we're not sure exactly what or how to structure these tables in the right way. And this is where the real challenge comes. I mean, we might have another problem where we have one single table, where we have one flat table that has all of our columns in there. And actually that's not the most suitable format for Power BI. We still want to be able to model our data to be able to have that slice and dice capability. And it's better to do that with separate tables. And here we've got separate tables, but we're not sure how to join them. And do we just keep them all as separate tables, blend them into Power BI, and then create the relationships between them? It's an option, but generally we need to think a little bit more about how we want to structure our data. And the context of those scoping questions that we've got and the metrics tracking will really help us in this exercise. So let's go back to the slides here. We define the data granularity and scope is the third step. And here the question is, how do we make sense of all of the data that we've got? And the answer is we categorize it. And how do we categorize this data? Well, we start to look at it in terms of dimensions and facts, and we can look at tables in this way, but also we can look at particular fields and see whether it belongs to a dimension or it belongs to a fact table. Now, dimension tables are the things that we slice and dice by. So these are the tables that are business entities. They're things like dates, like customers, like products. So they're business entities in their own rights. And if you think about a particular business entity, so we're looking at these relating to a business process. So what are the things that would explain this business process? These are typically the things that we would have on the axis of our charts, for example. And if we look at a particular business entity, that's what we call a dimension, it has a number of attributes. So for example, the date dimension will have a table for each date, and each date has an attribute. It has the attribute of day, which day of the week it is, which month of the year it is, which year it is. And all of these are attributes. Customers might also have attributes around what is their education level, what is their address, what is their date of birth. All of these things could be attributes of a customer business entity or customer dimension. And then when we come to these are the things that we want to slice and dice by. So you typically have, say, a line chart that has date on your axis. So date is one of the things that we'd have on our axis there, or we would have customer attributes, so we might have it by customer education level or profession, for example. So these are the things that then categorize our tables of data that we want as dimensions. And then we also want to make sure that we have one row per value here. So in our date table, our date dimension table, we want to have one row per date. We don't want to have multiple rows per date, and we don't want to have, want to have missing dates in there. We want to make sure that it's complete. So our list of customers is all our customers, whereas our list of dates is all of our dates in a particular range that we want to look for. So that's our kind of dimensions tables, our attributes, our slice and dice, our explain tables. And then we want tables that are also fact tables. Now these fact tables will contain the keys to the business entities, so they will contain a date ID, or date actually, that will just link into the dates. They will contain a customer ID, so something that links it to the particular dimensions that it's by, so by those attribute tables. But it contains in itself then just those keys and just the numerical values, and very little else. So the fact tables, facts are the numerical data points that we're capturing as part of a business process. So for a sales transaction, it might be sales price and quantity purchased. For our transactional process of recording accounting entries, it might be debit and credit values. And at least one of these facts should be additive, so where it makes sense to add values together. So for example, sales amount. If we just have balances, we should potentially look at having those in a separate table, and we can have more than one fact table. We don't always have to have the same fact tables, and where we have different granularity of those amounts, so we might have sales amount by date, by customer, by product, but actually we have budget amount only by product and month. So we might have data with a different level of granularity, and that's fine. That means we can have some facts, some numerical values by some attributes, and some other values by other attributes. So we can have multiple fact tables in our data model. So we need to think about having some additive facts, and where we have semi-additive facts or non-additive facts, so things like balances or unit price, those are also useful, though we have to think about different ways of potentially modelling those. Ideally, we want to, if we can, we want to make sure we do have some additive facts, some numerical values in our data model that we can sum and count. And then we also want to make sure that the facts that we capture are directly relevant to the business process. So if our process is sales, we want to make sure we capture facts around the sales amount and those kind of things, rather than say the salary of the person who was serving the customer. That's a numerical value, but not necessarily directly relevant to the business process that we're looking at. And so these fact tables are calculated for given combinations of dimensions. And when we're thinking about our data models, we'll have these as relationships. So we'll have relationships between our dimension tables, which are one row per value, and then for each one of those we'll have that key repeated multiple times. So if we make more than one sale on any given date, we'll have date repeated multiple times in our fact table, and again we'll likely have the same customer repeated multiple times if they've made multiple purchases. And this is where we get our one-to-many relationships between our dimension tables and our fact tables. So how do we go from understanding what facts we have and what dimensions we have those by, and what granularity of those dimensions? So say we might have different granularity of dimensions. We might have one by month and one by day. So for that we could use a gold standard technique for data warehousing called the bus matrix. And you can look at this online. It's from Ralph Kimball. So the Kimball method of data modeling is something that Power BI works very well with. It's the star schema data model, which is dimensions and facts. And there's lots of nuances to this as well. And the bus matrix is one of those ideas for how you capture which facts you've got or which business processes you've got by which dimensions. And we can see here in the simple snapshot, we've got ticks and crosses. So we've got business processes, and this might be processes or it might be actual facts, actual numerical values that we identify here. And then we say which dimensions do we have them by. We have a cross in the table to say we have all of these numerical values by these sets of dimensions. And that allows us to be able to then understand which facts we've got, or which can be combined into single fact tables, or where we need to keep those fact tables separate, and also where we've got potential joins and relationships in our tables that we can introduce. So let me show you an example of a bus matrix, and again it's something that I've put a template together for you to be able to download. So if we have a look here, so the bus matrix, so this is based on this same kind of finance data, and what I've done here is it's a slight modification of exactly how the bus matrix works. For a start, I've inverted it. I find it a little bit easier to have your facts, your numerical things along the top, and then your dimensions and all of the other attributes down the side. I've also not actually necessarily pulled out specific dimensions per se here, but where we've got a table with numerical values, I've put them here with the numerical values, and then where we've got that table, and it might be the same table, there might be other tables as well that also have attributes and descriptive values, there you go here. So what I've done to populate this is just take the data and look through each of these tables and say, okay, well, we've got a numerical additive value here, net amount and gross amount. Let me put that here under journals, net amount, gross amount, and then let's see what we've got those by. So let's start to then look at particular tables, and also we've got some descriptive values in here. So I've put journals in here as well. So to populate this, I've just copied and pasted all of the columns, pasted them, transposed them here, and then taken out any numerical ones that we've got here, so net amount and gross amount, and here we have all of our rest of our references, and I've just grouped that to say these are columns of this particular table, and these are the descriptive ones that we want. So then we can populate these for all of these tables, and again I've just kind of grouped these tables, these columns together. So these are your numerical columns, and these are your attribute ones. And we always start with, even if we don't have this table as our data source, it's very often if we have dates in our data that we should then map it against the calendar table. And we can see here then I've also mapped which specific dates, because there might be more than one date in here. And then we need to think about how we want to deal with multiple dates. So we've got journal date and journal created date. And here in this table we've got purchase orders, we've got purchase order date and delivery date. So here's something we can then think about with dates, and then for the rest of them we just look at the table and look at these numerical values and say, well, what else do we have this by? So we have, if we go back to the data in we have a look at the trial balance, we can see that we've got the debit value and the credit value, and we've got it by account ID. And because chart of accounts is also a separate table, if we scroll here we can see chart of accounts, account ID, and then we've got all the attributes of that account ID. So we know that we've got our trial balance, we have it by our account ID, so we have it by account. So we can go back into here and say our debit value and our credit value we have by chart of accounts. So we've got a tick in both of those. So I've just done it against the top row of that, and the rest of them are all the numerical columns in the charts of accounts table. We also, you have seen, we do have account details in there as well. So we have an account name, but actually we don't need that because we've got the ID, and that's enough to link to our chart of accounts table. So here then we've got all of the columns, and actually what I've highlighted here is the columns that we think we want as well, because one of the really important exercises, and this comes to defining the scope of your reporting, is to understand which columns you actually want to use. So which columns are actually necessary for you to bring into your reporting. And this is where the questions come in, because you need to understand what questions you want to be able to answer. So for chart of accounts, we want to be able to look at it by class, by whether it's an asset or a liability. And we also want to be able to look at the reporting code name. If we look at the data on there, that's quite useful. It's for us to be able to look at our chart of accounts. It's the actual header line that we need, so that will be really useful for us to work out and type. But actually the rest of them we don't necessarily need. We haven't got any questions that relate to whether it enables payments to account, whether it, the status of the account. We could bring those columns in because we think we might need them later on down the line, but what this will create is just noise in our data model, and it will increase the size of our data model. So we should always make sure, actually as a first step, that we limit the number of columns in our data model to just those that we need. And it's our scoping that's enabled us to identify which ones we need. And that's how we can highlight these here in a slightly different color. I've done it here, we can do it a different way as well. So we go through all of these tables. As I say, where it's got numerical values as well as descriptive attributes, we can put that table as both a fact and a kind of dimension here. And now we've got a view of where we've got our particular dimensions by which facts. We can see, for example, our trial balance, our debit and credit values, we have by chart of accounts and organisational units, but we can't relate that back to journals or to purchase orders, contacts, bank transactions or invoices. Those might be fact tables in their own right, because journals we can have by we have again by chart of accounts and organisational unit, but we also have some descriptive values of journals. So we can have a journal dimension table that has journal ID and then has some other details of journals. So even though this is one table, we're splitting this out into numerical values and its descriptive ones. And actually, if we don't need to do analysis on particular journals or particular attributes of journals, we don't need to include this table, but that could be quite useful. Now what we can use this for is to then understand which fact dimension tables we need in our data model. So where we have this certain facts that are by the exact same set of dimensions, or at least the set of dimensions that we want to analyze by, we can combine them into a single fact table, potentially, if they relate to the same business process. So we could say if we had trial balance and journals and they were all by the same set of dimensions, we could then say, actually, let's bring that into our single fact table, and then let's have these by these dimensions. In this case, we probably want to be able to track the journal ID and the purchase orders. So whilst we can have two fact tables, so we can have journals and trial balance here, and then the trial balance one will link to chart of accounts and organisational unit, and the journals will link to those two as well as its own ones around journals and potentially purchase orders. So again, we can now look at where we can combine tables. We can look at which ones we have by which granularity, and we can start to understand what our dimensions and facts should start to look like. So a very useful exercise. I'd recommend doing a bit more research and looking up on bus matrix as well, and having a go at populating this template. Just coming back to the slides, the bus matrix is a very useful technique. And then the other thing to really think about, as I was saying, was granularity. So I've taken this example here for New York City taxi trip data. So I've got a video on this where I've talked about this idea of aggregations. So this is a huge database. It's 2.3 billion rows of data, and too much to just bring in at that level of detail into Power BI. And we can see here we've got then our facts along the top, so trip count, fare amount, tip amount, and then these are all our kind of dimensions. And this is another alternative layout for this kind of matrix, where here I've kind of categorized some of these as well. So we've got date, year, month, date, so we can see we've got all of these measures by every single one of these very specific details. So the rain in inches, the temperature in degrees, the longitude and latitude of the pickup. And one of the things to think about then is, especially when you're working with very large data volumes, do you need to bring in data at that level of granularity, at that level of detail? And in this particular example, when we looked at the potential audience for this, who was taxi drivers or potential taxi drivers, we said, well, actually, do they really need to know whether, it was 70.5 degrees Fahrenheit or 72 degrees Fahrenheit? Probably not. They just want to know whether it was a hot day or a cold day. Same with rain. They can have that. They don't need that specific detail. They could just categorize that as it was raining or it's not raining. And potentially also with longitude and latitude, potentially all we need is the county, zip code, and maybe area, but we don't necessarily need to know specific long and lats unless we want to start plotting particular journeys. So what we can do is then use this to also understand where, again, referencing back to our scoping template and the questions we want to answer, where we want to potentially aggregate our data and exercise row reduction. And that's what we can have done here with this example, where we've said we can actually just bring this up into rain category. So we can say, wait, it's not raining or not raining, temperature category, passenger count, well, the number of passengers, and we don't need the time of pickup, we just need time bucket, which we have as an attribute. And we don't even need, actually at this level of detail, we don't need a specific date, because we're looking at such a large period of time, such a huge volume of data. Actually looking at it by year and month is more than sufficient to give us that view that we need. If we were doing a much more detailed analysis on journeys within a particular week or particular month, maybe then we could have date on there. But again, depends on the type of analysis you're doing, the types of questions you want to answer. But this would be able us to get us down from 2.3 billion rows to 1.8 million. So a significant reduction in those data volumes. So that's allowing us again to define the granularity of those. So we can use the bus matrix to look at the granularity and then look at how sensible that is and define the granularity that we want in our data model, as well as the scope, which fields are going to be relevant for us, which ones do we have facts by, which of those attributes, dimensions do we have our facts by, could we potentially combine tables into one, do we want to keep them as separate fact tables, do we even need all of those fact tables? All of these things we can start to look at by using these mechanisms and these templates. So now we come to the last stage of designing a data model, and this is to conceptually design it. So to show the kind of tables that we're going to have and the attributes in our tables, and we can do this using what's called a star net diagram. And I'll show through the template, and I've got another template that in Word that you can download to use for it. But bear in mind, again, this is not a technical document, or it's not a technical implementation of an idea. So actually you can run through this with completely non-technical business users and use this to shape the requirements for how you want your data model to be designed and structured. And it's worth going through this planning exercise before building it, because this will give you essentially your blueprint for what you need to do in Power Query to shape your data, to give you the right data model that will be able to answer those business questions. So over here in the last step is the conceptual design and data model. So what we do is we start with our measures, and we're doing this for each fact table. So trial balance was one of our fact tables, and in there we have debit credit, total debit value and total credit value, and we can just put that in a circle that has our in the middle of our diagram. So we start out with our diagram with a circle that contains our fact table and our debit value and our credit value. So this is our fact table. We have each star that we're designing here that consists of a fact table. As I said, we can have multiple fact tables in our model, and each one of those will be a separate star, as we'll see in here, a separate star net. So here we have a trial balance, and then what we do is we draw out some dimension tables that we'll have on there as well. So what would we want to view and filter these by? These are the legs of this star net. So our first one is, say, organization unit. So we can just draw a line from our circle to organization unit. And then on here, we want to put the attributes that we identified as relevant for reporting, relevant to the business questions that we want to answer. So we can have a look here in organisation unit, and we pick out, there were lots and lots of columns in this table, lots of attributes for organisational unit, but we only wanted to pick out a few specific ones that were relevant for what we were looking at, and those were currency, country code and legal name. Nothing else was really relevant for the type of reporting that we wanted to do for organisations. So we just mark those, and we put them as lines here, and we mark them as nodes on our leg here of organisational unit. And then we do the same for, again, we can see these from the bus matrix. We know what we have the trial balance by, we know which dimensions we've done it. So if we've done that exercise, that bus matrix exercise before, then going into this exercise will be very useful for us to know then how to physically design this model and what we want to bring out. So we did this for the next table, which is chart of accounts. And chart of accounts, again, there were only a couple of fields in here, a couple of attributes of those accounts that we wanted to bring in, and they were reporting code name, type and class. And these are denoted on the star net with a circle as opposed to a line because they represent a hierarchy. So reporting code name, type and then class is in that order. So asset liability, and then the detail, I think, of the next header line, and then going back down into reporting code name. So this is now then chart of accounts. We've pulled up those nodes that we want, those attributes, and we've put them as part of a hierarchy. And then the next one on there was date. Now, date was interesting because actually our trial balance is monthly, so we only have an end of month date on there. So actually it's by month rather than by date. But date is one of those, for any other dimension, would probably have to have unique values for those. So in this case, unique months as part of our separate dimension table as at that level of granularity, because it needs to match the level of granularity of the fact table. In the unique example of dates, actually we can still use a standard date dimension here, even though it's month, because we can just use end of month date, or we could have used start of month date, and that will still allow us to be able to do this analysis by profits and revenues by month, and then be able to look at that same period, that same data for our trial balance. So what we've done here is again put end of month date, and we're going to use a date table for that, and we put year, quarter, month as attributes, and again a hierarchy because that's a clear hierarchy, year, quarter and month. And we've also done another hierarchy for date, which is financial year, financial quarter, financial period. So we've got two different hierarchies there shown on the single, two different nodes but shown on against end of month date. So those are our attributes that we want to bring in. Now let me show you how this looks in Power BI. So I'll show you the Power BI implementation of this as well. It's the first time we're opening up Power BI desktop here. And we can see the first thing I've done is actually I could have just gone to new source Excel and then just brought in all the tables. But what I like to always do is set up a staging table. So have a parameter for a folder path and set up a staging table that has a link to just the raw data. So no tables within there. So this is just to the Excel file and it's referencing that parameter. So this is just a good pattern for bringing your data in. I'll cover it in more detail in a future session. And here we then have staging tables, and then I've gone in to reference each of these. So once we have this staging table reference, we reference it and then bring in all the tables that we want. So I've got a few other reference staging tables as well for where we need to, for example, do multiple copies of it. So where we want to reference staging for journals, we want to reference it both as a fact table and as a dimension table, then we can do that. So starting with trial balance. So trial balance just takes our staging source, navigates to where the source is trial balance, permits headers, change type, those are automatic steps, and the first step we apply there is remove other columns. So we go into here, go into choose columns and just pick the column. So here we can go here and then choose columns, and here we want to choose only the columns that we want to select. So these are the only ones that are relevant that we want to choose. So we're actually not interested in year-to-date credit and debits because we can calculate those as measures in our report, and we're only interested in the month. The account ID, we don't need account because it's one of the attributes from our chart of accounts table, and again organizational shortcode, we don't need a name because name's again an attribute of our shortcode. So we've removed other columns and just reorder those, and then that's our table there. Next, what we've done is brought in, if we now look at how this looks in the Power BI window itself. So we have our trial balance, and then we have our dimension table. So these are then our org units, our chart of accounts, and we've also got a helper table here. So we've done a slight snowflake here because we want to keep these as a separate table, and I'll show you what these FS lines are. They're to help us build out our reporting. So it's to have an ID, and then these on the P&L, and these are the balance sheet. These are all the headers we have on there, and then it has calc type, and these headers, some of these will relate to some of the types that we've got in our chart of accounts. So I've got a separate session in terms of showing how to do this, how this works, and I'll link to that here below, but this is a useful table for us to have. And then we also have a date table, and date table I've just brought in here using DAX. Again, I can provide the code for this. It's just an example of a standard date table with the attributes for all the dates that we need. And we've got our org units. So all of these join in using one-to-many standard relationships. So that's a fairly simple example. I want to then look at next example, and I'll go through these, show them in Word using the template, and then I'll look at how they're implemented in Power BI. So for purchase orders, we've included here from our kind of scoping template and from our bus matrix, we've got purchase order date, and again we've got the same hierarchy. We've got contacts, not really a hierarchy, but again we've got a contacts kind of dimension that it's linking to, so name. And you'll see here actually in the contacts we actually do have some numerical fields. So we've got the amount outstanding and amount overdue for an accounts receivable contact, and the same for an accounts payable contact. And that's okay. We can have some numerical values in our dimension tables because we're also potentially using those to categorize them. So we're categorizing it as to whether there is it's an account payable contact or an accounts receivable contact with an outstanding or an overdue balance. So we can then bring in those numerical columns, or actually bring in categories of those, so flags or statuses, for example, that could be quite useful, and then we can get rid of those numerical columns. And actually what we've done here is you'll see we've got some columns. So status was one of the columns in purchase orders, but we've also got two columns here that we identified from our scoping that wasn't part of the purchase orders table. So tax band and purchase order age category weren't part of that table, and I'll go back and show how to actually fix those, how to make those part of, how to bring those columns and calculate those columns so that we can bring them in here. But it's important to identify them as part of this matrix. I say this is the blueprint for what we need to build in Power Query. Organizational units the same. And then if I go back in here now and we look at Power BI and we look at how that's been applied, and if we now then go into, I'm not sure why that one's not loading, but if we have a look at our purchase orders, so we started off just here with our fact table. So I denoted all fact tables with an underscore. That's just a naming convention I like to use. Some people use dim and fact, but those terms don't necessarily mean anything to business users. So it's just a naming convention I've adopted where you just have fact tables with an underscore, and they appear at the top then of the fields list. So that's just taking the source and moving the columns. So actually purchase orders is by line item. So actually if we look at the source, we've got some columns here which are by line item, so by line item ID and line item amount, and then we've got some that relate to the purchase order, i.e. the combination of line items, and that's where we've got then we've got subtotals and things like that, total tax, total discount, total. Those actually all relate to single purchase orders. So these purchase orders are not unique. If we kept duplicates in here, we'd be able to see that. Just do that as an example. We should be able to see that there are actually multiple examples. Oh, right, it's because I've got the Excel file open. Just bear me a second. That's why this is complaining. Let me close the data. That should now refresh. Yep, if we keep duplicates, we'll see that these are duplicated. So if we actually just filtered for one of these, we can see that there's 3 lines on this purchase order. So what we want to do is for our fact table, we want to keep it at that granularity. So we've got purchase order repeated multiple times, that's absolutely fine. And let's just delete those steps. But we only keep those columns that relate to line items, not the ones that relate to purchase orders, because that makes no sense. We're looking at the granularity here of line item. So we keep all of those line item ones and remove any other columns that relate to the total purchase order. But what we can also do is reference that table, and here we want to have one row. Now we want to get our dimension table to one row per purchase order. So for here, you can either use remove duplicates if you've got duplicates and you just want to remove them to one row and you know they're all going to be repeated. But here, for where you've got things like line items and header level detail, it's better to use the group rows functionality. So we've grouped by purchase order ID, status, date, and these were things that relate to a purchase order. And we've done some columns, which is the sum of line item amounts, or the sum of that, and where it's a column that relates to the purchase order itself, we can just do max. So actually we've calculated some of these totals ourselves and also brought in some of the totals that they gave us. And we can use these columns, and the reason I brought in date in there as well is because then we can create our calculated columns here. So we can do tax percentage, which I've just done here as total tax divided by subtotal, and age was one of the ones we had on there, which is why I brought in date on here. And then we've just done, again, date time local. So we've just added column, gone to date, and gone to duration, and then been able to add those in there. We've extracted the days out and added conditional columns to give us the category. So for tax band, if it's greater than 25%, say we've done high, medium, low. This is obviously logic that I've just kind of made up for illustration purposes. And we've done that same for the age category. And then we've removed those other columns. So now we have our unique purchase order IDs, the status, the tax band, and the purchase order age category. So now if we look at this in the data model, we could look at purchase orders, and we can see that we've got then contacts, purchase orders. So this is our purchase order dimension table, and because it has one row per purchase order, it links into the line item fact table. And we've got organizational units, and again we've got a same date table. So it's better to use the same date table if we can. It's a shared dimension, and that way we're able to slice and dice by a common date or a common set of dates, a common month, a common year across multiple fact tables. And lastly, let's have a look at journals. So if we have a look in here, so for journals we've got two dates in there. The rest of them is the same, and actually we've done a similar concept here for P&L, balance sheet, impact and gross amount. We've got the same thing where our fact table is actually by line item, and then we've done a group by and done whether it's balance sheet or P&L account, and then calculated the impact. I'll share the file. But for dates, we've got two sets of dates. We've got journal date and journal creation date. Now we can either implement this in one of two ways. We could either do them as the same. So we could actually do either journal date or journal creation date, and then or journal date. And then what we'd have, we could represent this in the star net as essentially the same. It could be either or, and then we'd have one date table and have two relationships. Only one can be active between our date table and our fact table, but what we can do is use relationship to switch between which one we want to activate in a particular measure. The other alternative implementation, which is what we've done here, is what's called role-playing dimension. And that's where we actually have two separate date tables. Now, which one you choose depends on the type of analysis you want to be able to do. If you want to view journals created and journal date on the same axes, or measure by both of those on the same axes, then you want to do the implementation where they're the same, where you use the same date table and you use relationship. In our particular case, if instead you wanted to say, look at all of the journals with a particular journal date or particular month of journal date, and then look at those by journal creation date, so how many of those journals were created in this week or created in this month, then it's better to keep them as separate tables, because you're able to slice and dice by two different sets of dimensions there. So just to show you the implementation of that, again in the for the journal dimension table, we've started with that. I've merged in the FS lines to bring in the type of statement, if it's a P&L or if it's a P&L or a balance sheet amount, and then pivoted that to get to our P&L and balance sheet amount. and grouped them, and then added the columns to say what is our P&L impact, what is our balance sheet impact. And again, I'll share this file so you can see how that's been done. And then in the implementation, in the data model, we've got their journals, and we've got with here, we've got organizational units, our journals dimension table, and then we've got 2 date tables. And this is just a copy of the other date table. So it's just journal created date, journal creation date is just equals to date. So just modeling new table, create a new date, and then we've got both of those joining, that one on journal date and that one on journal creation date. And again, we've got our chart of accounts dimension using the same table so that it then joins into multiple dimensions. If we look at those all together, this is a slightly more complex view, so it's better to have these separate tabs where you can see each star net, each star in its own view, and then you can see them all together. And what this gets across is the fact that you've got your single dimension table joining into your multiple facts. So that's the technical implementation. As I say, this exercise is a completely non-technical exercise, could be done with non-technical business users, and helps you to all get on the same page about how that data model is going to be designed and implemented in Power BI. Thank you very much for watching. You can download all the material for this session in the link shown here. Enjoy the rest of the SQL Biz conference. This session was actually a recording of the first module of a course that I'll be launching soon. So visit learndatainsights.com to sign up and find out when the course is released, as well as take some quizzes for now. And please reach out to me on LinkedIn or Twitter, and I look forward to having a conversation on. Thank you.